Last lesson of matrices. Okay, here we go. Inverse matrices. A lot of words, a lot of things going on this slide, but it's not too terrible. All right, now, an identity matrix, by definition, it's a square matrix that, when multiplied by another matrix, equals the same matrix. I'm going to put this in terms you understand. Now, normally you think of identities as, honestly, you should probably think of them as theorems from geometry, I guess. But when you do it by numbers, okay, let's take it to the number world. What is 2 times 1?
2.
2. Good. Okay. 2 times 1 is 2. 3 times 1 is 3. 4 times 1 is 4. Anything times 1 is?
The number. No,
that's wrong.
The number that's multiplied by 1.
Good. Anything times 1. See, I always ask that question backwards just to mess with you guys. Most people go 1 times anything, or well, whatever, you know what I'm saying? Anything times 1 is that anything. Okay? Now, put that up here in this definition. It's a square matrix that, when multiplied by another matrix, gives you back that same matrix. That's an identity matrix. For a 2 by 2, that identity matrix is 1, 0, 0, 1. It's your matrice form of 1. Okay? For a 3 by 3 matrix, it's 1, 0, 0, 0, 1, 0, 0, 0, 1. To be honest, this is the only time you'll see a 3 by 3 matrix today. Right here. Okay?
Does that mean we're going to see bigger or just 2 by 2?
Just 2 by 2s. Okay? We talked about this one a lesson prior with determinants, but square matrix. It's a matrix with the same number of rows and columns. A la, it looks like a square. Right? And then your inverses are 2 matrices that have the identity matrix as their product. Okay? We kind of hit on this the other day too. What's the inverse? Stone, give me a number.
I'm going to go with 3.
3. What's the inverse of 3?
Negative 3.
Negative 3.
Oh.
Now that is one kind of inverse. 3 has 2 inverses. Did you know this?
Yeah.
What's the other one?
1/3.
Very good. Do you know which one's which?
Yeah.
What's 3? 3 and negative 3 are what?
They're the identity matrix.
No.
I was on a roll.
You are on a roll.
Are they
3 and negative 3 are what? What kind of inverses?
absolute value?
No. This may be out of left field a little bit. So if you don't get it, don't feel bad. Don't go home and cry over it.
Yeah, I'm still right.
3 and negative 3 are inverses because they what?
They're exactly the same.
Because they're the same distance away from 0.
On the number.
Or they?
The same absolute value.
No. I'm still with Stone. They what to 0?
Equal
They
equal to 0. Added together, they equal to 0.
There you go. They add to 0.
add.
3 and negative 3 are what's called additive inverses.
Yeah, I didn't know that.
Right? I was a little out there. 3 and negative 3 are additive inverses. Okay? Now, why are 3 and 1/3 also considered inverses?
It's called inverse matrices.
I guess 3 over 1 and 1.
Then you multiply and you get
3.
No.
1.
1.
Sorry.
You multiply those two numbers together and you get 1. Multiplicative inverses. Big word.
Do we have to write this?
No. Okay? Multiplicative inverses. That's where these come. Inverses for matrices are 2 matrices that have the identity matrix as their product. Must work both ways because it matters your order of multiplication for matrices. Okay? Now, we're not going to so much verify that 2 matrices are inverses of one another. What we're going to do is be given one matrix and find its inverse. Okay? Make sense? And there's a formula to that.
So write down the.
You need that key concept box right there. For sure.
Wait, so. Can you explain how? Should we write it just like that?
To find the inverse of a matrix, you're going to be given a 2 by 2 matrix. Capital letter A, 2 by 2, elements A, B, C, D. All right? to find that inverse, you are going to first do 1 over AD minus BC. This is going to end up typically being a fraction. All right? You're going to have a fraction in front. 1 over AD minus BC. That should sound familiar to you. AD minus BC is the formula to the what?
The matrices.
No. Determinant.
Not discriminant.
Determinant.
Determinant.
Good. Okay? So it's 1 over your determinant times this different 2 by 2 matrix. Different in 2 ways from your original. The first way is you flip-flopped A and D. See how it's AD on the left and it's DA on the right. So you flip-flop the places of A and D. Secondly, you change the signs on B and C. Does everybody see that? So you flip-flop A and D's locations. You change B and C's signs from your original matrix. You make your determinant from your original matrix. Once you do that, you make these changes. You put the determinant under 1, and you multiply it through.
But
Harris.
If it's already negative, will we change it to positive?
Yes.
Okay.
Opposites.
So it doesn't.
Opposite signs. Yep. Shields.
So you start by doing AD minus BC, and then you multiply that.
And then you switch things. Yes.
Okay.
Others. Okay. We already hinted on this bottom part, this text down here. You don't need to write this, just think about this, okay? Notice that AD minus BC is the value of the determinant of A. We just talked about that. Therefore, if the value of the determinant of a matrix is 0, the matrix cannot have an inverse. Why?
Because there's no inverse zero. If there's a negative zero.
No. That's not wrong, but that's not why.
Like 0 can never be in the bottom of a fraction.
Bingo. And where's your determinant part of this fraction? In the bottom. You can't have 0 in a denominator. Ever. Right? So if 0 ends up being your determinant, where you'd have to force that is your denominator. There you go. Giving you 1 over 0, which blows up your problem, which means no inverse exists. Okay? Questions, Stone?
For her. On the one.
Okay. Everybody ready for the next one? Let's do it, huh? Find the inverse of the matrix. 7, -5, 2, -1. Step 1, find your determinant. So 7 times -1 minus -5 times 2.
3.
-7 minus, oops, hold on. Minus -10. 7 minus -10. 3. Okay, so you put that under 1. Okay, 1/3. And then now that you have that determinant, now you make the new matrices by doing the changes that you need to. You flip-flop these two numbers' positions, so -1 and 7. You change these two signs, so +5 and -2. Okay. Then you multiply that 1/3 all throughout. So -1/3, 5/3, -2/3, 7/3. Fractions are commonplace here, but typically that's the most you're going to have to do. And the nice part is that'll always be a 1 on top, right? So the most work you'll ever have to do is potentially reducing fractions. Okay. Okay, so it's not really like working with fractions too much. Fractions will be common in your answers. Make sure you always reduce your fractions. Alrighty. Okay, calm down, children. Here we go. 3 times negative 4 minus 7 times 1 gives you negative 19. Okay, Algebra 101. Right?
Yeah.
Okay, great. Times. Flip-flop these two positions. Change these two signs. Stone, I didn't know you were British all of a sudden.
Do you want to see this step where we switch them?
Yes, yes I do. And I didn't tell this to the other hour, and I should have. Make sure you show me this step. Okay.
The first step?
Well, here. I don't care so much to see you make the determinant on this because I assume you know how to do that now. I definitely want to see you do the switching though. All right, because that's kind of the new thing is how to switch this. Show me this so I know you know how to switch and where everything goes. If you go straight to an answer, I'm going to assume you got it from someone else, and you just went copy, paste, paste. So show me that you know how to do that switch up.
Where are we supposed to do the first one, right? How do we do one? Why do the second one?
So there's your first one, right? 4 19ths, 7 19ths, 1 19th, negative 3 19ths, yes?
Yeah.
Okay. Everybody good?
I have that.
Makes sense?
So can I make my suggestion again for number B?
Sure, what's B?
Is B 1, negative 1, 1, negative 1?
Well, did you find your determinant first?
1.
You sure?
That's
Zero.
so far along that it's not.
Because you gotta put, because
There's no interest.
See, you got to do the determinant first, okay? I don't know if I made that clear yet. You must do determinant. You must do the determinant before you switch. Okay? Determinant before you switch. So this guy's determinant. Negative 1 times 1, negative 1. Minus 1 times negative 1, negative 1. What's 1 minus a negative 1?
It's
0.
0. Which means you'd have 1 over 0, which means
No inverse.
does not exist. It's out of existence.
next. Shh. Next question. Shh.
No. 6.
6. We all know that, right?
Are you gonna throw like freaking matrices in there?
Yes.
Shh. Pause. This is 6. X is 6. We all get this. We understand this, right? How'd you get that?
Divided by 2.
Divide by 2. Good. That's the way you've been trained. You're acting the way you've been trained. Good job. I'm proud of you. What's the other way you could do this?
You could,
No. Guessing checking is terrible. Don't do that.
you could do, you could, subtract 2 over.
No.
2 well. You know, I'm thinking.
You just don't know that.
Yeah, there's like,
another way to do it.
Yes, there is.
Probably is. 2, 12. No, there's not. There's only one.
Well, he asked for one.
He also asked
Yeah,
us
he
for the
said-
whole.
Ah! Whoa! Whoa! Miss Williams. I thought.
No, I said it. What's on my head?
That's not the answer.
Oh, I thought you said something else. Dory.
Drop by half.
Multiply by 1/2.
Oh,
What? No. How? What?
where'd you get that? Wait, which bedroom?
Because. Shh. Hey. Because 2 times 1/2. These two numbers are what?
Wait, what?
Those two numbers are what together?
Inverse.
Inverses. Good.
Oh, because then it equals 1.
Bingo.
And then you can get the other side to.
That's weird.
Fascinating, ain't it? Okay.
That's right.
Fascinating, right?
Does that only work when you have a half though? Or when
No, it could be if that was 3x equals 12, multiply by 1/3.
So you're saying basically just multiply.
Okay, wait, let me
Okay.
can I put a number up there then? I just dropped that. Someone else speak to her.
Shh. Now, compare what you just did
No.
to what's up here.
Do we need to find a determinant? Determinant?
Why is a capital Y?
Because that's your matrix.
Good. It's a matrix because it's a capital letter. Okay? So this is a matrix times this matrix to get this matrix.
What?
Wait, say that again.
I will. You have a matrix here that's timesing by a matrix that you don't know
Right.
to give you this matrix.
Oh, so Y is a matrix.
Correct.
A whole matrix.
That's my
So I
point.
have to figure out why.
Focus.
Right.
You need to figure out what Y is.
So you gotta work backwards.
No.
You don't divide, right?
We can't divide
Exactly. So we have to times
by
the
the
matrix by the matrix's inverse.
bingo.
But
Good.
we need to find the inverse,
Very good.
And the inverse,
which we wrote down.
Very good.
which is the
So,
matrix.
shh. Find the inverse of the matrix that is next to your variable.
Oh, is it?
Stone.
Is it
Stone.
what?
Just quiet. Find this inverse. Let me get my finger there. Find this inverse first. Okay? So, -1 times 3 gives you
-3
-3
minus 2 or plus 2.
minus -2. Oh, it starts you off real nice and easy.
-1 over 1.
That's your determinant.
Okay.
Okay? That's your determinant. So, 1,
Not the inverse.
it's not the inverse, correct. So 1 over -1. I'm going to leave that as a fraction for right now, okay?
Okay.
Times the matrix next to y, which is, and now you do your switching.
3, 1, -2, -1. So it becomes -3, -1, 2,
Good,
and then you multiply that by the beginning one,
good,
and then you also multiply it on the other side,
good,
and you can do it because it has the rows and columns.
good. Did everybody follow Stone's freight train?
I've been trying to write this down. I haven't
Okay,
caught up.
shh, get caught up. Get caught up to the inverse. Okay?
Oh, that's actually kind of cool.
Now, before we write anything else down, realize this. You've done 0 work as far as actually solving this equation goes.
Yep, no, we've done it.
Stone, knock it off. The work you've done is to find the inverse that you multiply both sides by. That's the work you've done. Okay? Now, think about this. If this is this guy's inverse, by the definition of inverses, you're going to get the identity matrix when you multiply them together, right? Okay? That's what you wrote down earlier. Okay? If those two are inverses, you're going to get the identity matrix. The identity matrix in matrices world is basically 1. The number 1, right?
Yep.
Which means when you multiply this matrix times this matrix, you get 1 y.
Because 1 times 1. So
Okay.
we need to even multiply it out.
So you don't need to multiply this times the left side because it's going to give you basically 1. Or 1, 0, 0, 1, however you want to think about it. Okay, Harris?
I don't get how it's equal to 1.
It's the identity. It's like 1 and like the 2x equals 12 one we just did.
Yeah.
When you divide that by 2, what's your coefficient in front of x? 1. When you multiply this guy by the inverse, basically the coefficient in front of y is going to be 1, except it's going to be in matrices form, which is 1, 0, 0, 1. Because that's the identity matrix. Okay? Kind of, sort of? Rolling with it? Okay. So, what you do to the left, you do to the right. Okay? So, on the left side, we multiplied by -3, -1, 2, 1 in our heads, and we got 1, 0, 0, 1. Because by definition, that's how it works. What you need to do now is multiply the inverse by this. Okay? Now, be careful when you do this. Because to my knowledge, it has to go inverse first, this second, unless you're told otherwise.
Is this the other one?
You will be told otherwise in specific problems with specific directions. Okay? Until that happens, you go inverse first, your other matrix second.
Wait, inverse first?
Inverse first, your other matrix second. And then multiply the two. Okay? So negative 3 times 8 gives you negative 24. Plus negative 1 times negative 19. So positive 19. So negative 24 plus 19 gives you what?
5, negative 5.
Multiplying the two matrices together, right? Do your second one. 2 times 8 gives you 16. 1 times negative 19 gives you negative 19. 16 minus 19. There's your answer.
That was a lot of work.
Dimensions, that's the one.
There you go. Dimensions. That's what you wanted to
You
say.
can do it. So negative 2 and is it negative 2 and negative 6? So it's positive. Oh, it's not a fraction.
Everybody catch that on how you start this one off. Subtract that 611 matrix over. Okay, since it's a plus 611 here, you minus 611 over here, get it gone. Okay. Now, same steps. Find that determinant first. Okay, so negative 1 times negative 3 gives you 3. 3 minus 0 gives you? 3 minus 0, or 0 minus 0 gives you? Let's say 3 minus 0.
Yeah.
Oh, my bad. 0 times 0 gives you?
0.
0. 3 minus 0 gives you?
0.
3. Okay, sorry.
3 minus 0.
So your fraction's 1/3, right?
That's the discriminant.
Determinant.
I don't know why I keep saying
Flip-flop those two, multiply it through. So you get negative 1, 0, 0, negative 1/3. Huh? I'm giving you guys a fraction?
Oh, because the other one was a whole number.
Oh, you poor things.
So now you just do that one to the negative 2, negative 6.
There you go. So now bring this guy down. And multiply them. So negative 1 times negative 2 gives you 2. 0 times negative 6 gives you 0. So 2 plus 0 gives you
0 or 2.
2. All right. 0 times negative 2 gives you 0. Negative 1/3 times negative 6 gives you
Negative 1 over 18.
no.
Or negative 2.
No.
Negative 2.
No. 2. Negative 1/3 times negative 6.
You put 6.
Oh, you'd be on the top one then.
Mm-hmm.
Oh, and then 6 over 2.